Okay, so we are on to 2023 question 10B, and this is in paper 2. Seamus needs to pick a new PIN code. It must be a 4-digit code. So I'm kind of visualizing here 4 boxes for his code. It must use exactly 4 of the digits from 1 to 9. So 0 is not included here. So if I'm using 1 to 9, that leaves me with 9 choices. Now, no digit can be used more than once. So I've 9 choices for the first, but then I only have 8, 7, 6 for the rest. So that's, and of course, it's the fundamental principle of counting. So we multiply in between each one, 9 by 8 by 7 by 6. So there's 3,024 ways we can do that. Work out how many of these codes contain the digit 2. Now, it still has to be a 4-digit code. So maybe a good way to think of this is, let's say, for example, we place 2 in the first position. So we've only one choice. We have to put 2 there. Now, once I've used 2, that leaves me with 8 choices, 7 choices, and 6 choices. But of course, the 2 doesn't have to be in that position. So for example, the 2 could be in box 2. So I have one choice there, but I'd still have 8, 7, and 6 for the rest. Or I can have one where the 2 is in the third box. So I can have one choice there, 8, 7, and 6 choices for the other boxes. Or I can put the 2 in the last box. So I have one choice there and 8, 7, 6. And of course, I'm multiplying these. So really what you'll notice is you'll get the same answer in each of them. So if you want, you can just do 1. So I'll work that out. 8 times 7 times 1 times 8 times 7 times 6. So that's 336. Now, because each of them are 336, if you want, you can just multiply by 4, if that makes sense, because each of them is going to have that value. So you basically add up the 4 of them or multiply by 4. So there's 1,344 ways that you can do that. Okay, last part. Work out how many of the codes in part B, part 1. Now, B part 1 is a 4-digit code and no restriction, like just numbers between 1 and 9. So work out how many of the codes in B part 1 have the sum, have the sum of their first 3 digits equal to their 4th. This code can contain the digit 2, although you do not have to. Okay, so they're basically kind of saying part 2 is kind of irrelevant to this question. Okay, so because this involves a sum, we're kind of going to have to really list, choices here. So I suppose the first thought in my mind is when I go to pick numbers, if I pick ones that are very high, like say, for example, if I was to pick the digit 5, 6, 7, and 8. Now, if I pick 5, 6, 7, and 8, so let's just look at this for a sec. The idea here is that the first 3 should sum to the last. So if I add 3 and 6 and 7, that's 18. So because these numbers are larger, it won't give us the last digit because it'll be too small. So I suppose for that particular reason, I'm thinking, let's start with the lower numbers. So let's start with, say, for example, if I pick 1, 2, 3, and 4. So is it true that if I was to add the first 3 choices, 1, 2, and 3, would that give me 4? Well, it doesn't give me 4, but it does give me 6. So the 4th digit doesn't have to follow on. So in other words, if I use 1, 2, 3, and 6, it's true that my first 3 choices add to my 4th. So that'll work. So that's definitely a choice. So I suppose on that line of thinking, maybe if we try 1, 2, and 4. So 4, 5, 6, 7. So am I allowed to pick 7 as an option? Absolutely. So I'm happy with that. Let's say I pick 1, 2, and 5. Well, that adds to 8. And is 8 on my list of possibilities? Yes, it is. What if I add 1, 2, and 6? That gives me 9. So that's possible. Now, what if I tried 1, 2, and 7? Well, if I try 1, 2, and 7, I get 10. Now, 10 is not an available option. So the fourth digit is outside of my 1 to 9 choices. So for that reason, that's not a possibility. Of course, the first one I wrote down, I mean, that's what was that again? That was an 18. So obviously that's definitely not a possibility. So we might just clear that so we don't get confused. Right. So I suppose the question is that it then? Is it just the 4 of them? Well, I suspect that maybe we might have a few more if we use some of maybe the other numbers as well. So maybe if we tried like 1, 3, and 4, something like that. So if we try 1, 3, and 4, that's 4, 5, 6, 7, 8. That's 8. So that's a workable option. We could try 1, 3, and 5. That is 9, and that's a workable option. So we've 1, 2, 3, 4, 5, 6 at the moment. So let's see. 1, 2, 6, 1, 3, 4, 1, 3, 5. Yeah, so I've used all those options for the 1 plus, but I suppose I haven't tried, for example, 2. So let's say I did 2, 3, and 4. So would that be an option? 4, 5, 6, 7, 8, 9. So that actually works too. Now, if I go any higher than that, like for example, use a 3, 4, 5, something like that, they're going to be too high from there on. So we have 1, 2, 3, 4, 5, 6, 7. So we have 7 things there that'll work. So in other words, 7 choices that we could make where the first 3 digits add to the fourth. But I suppose the other thing to bear in mind is we don't know, like, is it in the order 1, 2, 3, and then 6? Well, we don't know that. In fact, each of them can be in any order, not the last digit, but the first 3. So for example, if I was to change this around and write 3, 2, and 1, would that still give me 6? Absolutely. Now the 6 does have to be in the fourth position, because remember, it has to sum to the fourth digit. So the 6 has to stay, the 7 has to stay, the 8 has to stay, etc. But I hope you can see here that there is a choice of 3 for the first position, choice of 2, and a choice of 1. You have a choice of 3 here, a 2, and a 1. In other words, you could have put 4 there, and 1 there, and 2 there. You know what I mean? So you'd have a choice of 3 here. You could have picked the 1, the 2, or the 4. You have a choice of 2 then. So let's say you use the 1. Well, then you have a choice of 2 or 4 in this position. And then whatever you've used, well, you've only 1 left then, which is why that's a 1. So each of those has a 3 by 2 by 1 chance. So each of them has 6, each one of those has 6 ways of being arranged. So that is why at the end I multiply by 6, because yes, there are 7 combinations that will work, but we also have to consider that when we're picking the digits for the code, they don't have to be in the order 1, 2, 3. It can be like 2, 3, 1, 1, 3, 2, etc. So the final answer really is that there are 42, work out how many of the codes. So 42 codes is what we should be writing. Have a sum where the first 3 digits adds to the fourth.